Now we get into the properties of equality that are really going to help us when we go to do the work of solving equations. The first basic technique that we have for getting an equivalent equation is called the additive property of equality. And I'm going to state the property, and then I'm going to show you a couple of examples. So the property is just this. For any real number a, if we have an equation that says that x and y are equal, that's an equivalent to an equation that says x plus a and y plus a are equal. The two equations have the same solutions. Another way to phrase that is, we can always add the same number to both sides of an equation without changing the solutions. Of course, that without changing the solutions is the key idea here. That when we add this number to both sides of the equation, we get a new equation with exactly the same solutions as the old equation had. So, for example, if we know that 2 plus 3 equals 5, which it is, right, no matter what value any variables have, this is certainly true. We can add 7 to both sides of that and say that 2 plus 3 plus another 7 is equal to 5 plus 7. Again, that's true. Okay, so that's kind of a trivial example, right? There are no variables here. It's easy to see that this is true. Well, here's another example. If we know that x equals 4, we can add 7 to both sides of this, and we see that x plus 7 is going to be equal to 4 plus 7. That is, x plus 7 is equal to 11. Right, and again, we can see that that is true. We started out by noting that x equals 4, and so when we substitute that, we see 4 plus 7 really does equal 11. Okay, well, why is this actually useful? Let's see one more example. Let's say that we know that x minus 5 equals 2, and we decide to add 5 to both sides. Then we would get x minus 5 plus 5 equals 2 plus 5. But now if I simplify what I see on the left, right, minus 5 just means plus negative 5. And now I can use the associative property to add the negative 5 plus 5. On the left, I just get x plus 0. On the right, 2 plus 5 is 7. I get that x equals 7. Notice, this equation only has one solution. It's just what it says, x equals 7. But this equation and this equation have exactly the same solutions. So that means that x equals 7 is the only solution to the first equation. And it is true that if we substitute 7 for x, 7 minus 5 really does equal 2. Now I said that this was a property for addition, right? Notice that subtraction inherits this property. We can just add the opposite. The other thing to be aware of is that we sometimes shorthand using this property by, instead of copying everything and writing a line that looks like this, just writing the term to be added underneath any term that's like it. So for example, if we start with the equation 2x plus 3 equals x minus 7, and we decide for some reason that we ought to add 3x to both sides, well, we'll write a 3x on the left-hand side underneath the x term, because that's what we want to combine it with, And we'll write a plus 3x on the right-hand side, also underneath the x term because that's what we want to combine it with. And then we'll actually carry out the addition. 2x plus 3x is 5x. There's nothing to be combined with 3, so that stays. X plus 3x is 4x. There's nothing to be combined with the 7, so that stays. Right, so this is just a shortcut way of writing. What we've actually done is to add 3x on both sides of the equation, and then simplify each of these expressions by combining like terms. Note what we mean by both sides of the equation. The equation says that two expressions are equal. This expression over here and this expression over here. If we proceed to add 3x to each of those expressions, the resulting expressions are still equal. That's what this property is telling us that we can do.